सब ज्वाइन हो चुके हैं? Everybody has joined. Everybody has joined. Turn on your cameras. We'll begin with part 2. Next session will begin now. How many people have joined? Okay, I think everybody has joined, right? Turn on your cameras, okay? Am I audible? Clear? Okay, we'll start with second part. What is the second part? Second part is about resistance and resistivity. We're going to start with resistance and resistivity. That means in the circuit, there is somebody which tells current, stop, wait, do not flow too much. And then we are going to see how to use the resistors in a combination. That we are going to study in the current session. Okay. So let's move ahead. So what happened is some group of people experimentally what they did, they made a circuit. Okay, in that circuit, they had a resistance, they had a battery, and they had an ammeter also connected. What they had? Ammeter. What ammeter is used? Ammeter is used to measure the current. Okay, what they found? The first observation what they found is, okay, the ammeter, what they found, the ammeter showed half reading. Ammeter reading आधा हुआ when the length of the wire was double. If the initial length was L and the reading of the current was I, when the length of the conductor increased by double, that time the current reading showed as half. That means I by 2. When current decreases means resistance increased. No, it means that resistance increased. What happened? When length increased, resistance increased. That means resistance is directly proportional to length. Resistance R is directly proportional to length. Why? Because current halved when length increased. What happened? When length increased, current became half. Okay. Next observation. Next observation, we played it with area. First, they stretched the wire, they increased the length. Now, what they did? They increased the thickness of the wire, they expanded the wire. What happened then? They found that the reading of the ammeter increased this time. When the length increased, the current decreased by half. But this time, when the thickness was doubled, that time the current increased. What does that mean? Current increased when resistance is decreased, right? What it means? Resistance is inversely proportional to area. It is 1 by A. Okay. That is this is what they found in experimentally they found. Okay. So that means from here what we get to know that R, that is resistance, is directly proportional to the length. Resistance is inversely proportional to the cross sectional area, and this we already know. Current is inversely proportional to the resistance. So with this we can conclude that resistance depends on length. Resistance depends on length, depends on area, inversely depends on area, and the nature of the material. Nature of the material is called as rho. Resistivity. Resistivity is called as electrical sensitivity or electrical resistivity of the material. It does not change with shape or size. That means if copper wire is increased in shape or size, the resistivity does not change, but resistance will change. Resistance and resistivity are two different things. Okay, they're two different terms. Okay, resistance depends on length, area, and nature of the material. But the nature of material depends on, what does it depend on? It does not depend on shape or size. It directly the nature of the material itself. Okay. So resistivity depends on material and temperature, but does not depend on length, area, shape or size. तो रेजिस्टिविटी ऑर्डर इज द कितना रेजिस्टिविटी है एक एक चीजों का, मतलब वो मेटल metal has the least resistivity. Metal has the least resistivity. After that, we have alloys and then insulators. Metals will say, chalo bhai, you can pass as much current through me as possible. That means they are good conductors. Alloys also will say, ठीक है, you can pass as much current, but not as much as metals will, not as much as you can pass through metals, slightly lesser than metals. Okay, because the resistivity of alloy is slightly higher. Then insulator, what happens? The resistivity is very, very high. 10 raised to power of 12 to 10 raised to power of 17 ohm meter is the resistivity. Okay. So then metals are conductors like copper, aluminum. Then you have alloys, and under alloys you have nichrome. And in insulators you have rubber, glass, paper, or diamond. So when you are touching any electrical circuit, it is always advisable to use rubber. Okay. You cannot stand on diamond, it is too expensive. Or you can take paper, newspaper, you can take and stand on newspaper. Okay. But diamond, if you take, diamond you will not able to afford, right? Even I cannot afford diamond to keep under my feet and catch the electric plug, right? So we will use paper or rubber. So this is the formula you need to remember for resistivity. Resistivity formula is resistance, R. R is resistance. A is the cross-sectional area and L is the length. So as you see here, for same material, if it is a copper, okay, of any size, shape and all, the resistivity rho will remain same. If it is graphite or some carbon related item, it's the same carbon related item, so rho will remain same. Okay, this one you ignore. Property of the material. Rho is the property of the material. Resistivity is the, what is resistivity? It's the property of the material. It is independent of shape and size. So these are the different materials actually. And the resistivity, this is given in your NCERT textbook. This is taken directly from your NCERT book. Okay. So for conductors, it is given. Then for alloys, and then for insulators. You can see the values here, and you'll understand that conductors and alloys have low resistance, and hence they allow the flow of current. But insulators have very high resistance, so they will not allow the flow of current. Okay. So let's go ahead. Problem. Can you try solving this? I'll give 5 seconds. In 5 seconds. 1, 2, 3, 4, 5. क्या दिया है problem में? Let's see who wins 1 crore rupees. Okay, it is asking here how much current. It is asking about current. How much current will an electric bulb draw from a 220 volt source if the resistance of the bulb is 1200 ohm? And second part of the question is how much current will an electric heater coil draw from the same source if the resistance of the coil is 100 ohm? So what is given here? Current we need to find out. Okay, resistance is given, voltage is given. So we have to use Ohm's law here, right? We have to use Ohm's law. Ohm's law can be represented as current is equal to voltage divided by resistance. And then for the bulb, we take the bulb first. V is the voltage, R is the resistance, 1200 ohms, and we will get 0.183 amperes. For heater coil, same thing we do. We just take the heater coil ka voltage is the same, 220 volts. 220 volts divided by 100, we'll get 2.2 amperes. So final answer is 0.183 and 2.2 for the heater coil. If you didn't understand the solution, you can type in the chat. Okay, you can use chat whenever you need to ask me any doubts. Second problem, next problem. Try to solve this 5 seconds. Anybody has the answer can type it in 5 seconds. Tick tick 1, tick tick 2, Tick tick 3, tick tick 4, tick tick 5. What is asking? Nobody has typed the answer, right? Nobody has typed the answer yet. Okay, so let us solve it now. What is given here? Resistance of the metal wire length is 1 meter. Always while solving the problem, first you see what is given always, right? Length of the wire is given, then resistance of the wire is given and at 20 degrees Celsius. Diameter of the wire is given as 0.3 mm, and then what will be the resistivity is asked. So we'll use the resistivity wala formula, right? We have to use the resistivity wala formula, find the resistivity and then map the resistivity to know the material of the wire. So let's solve it. The formula here we use resistivity wala formula. Here the R resistance R is 26 ohms. Resistivity is what you need to find out, right? First we can calculate the area given the diameter. So diameter is given. If diameter is given, radius will be half of the diameter and it is converted into meters, right? Meter conversion is 10 raised to power of minus 3. So the area is found, that is 7.07. Then we rearrange the formula for finding resistivity. What we need to find? We need to find resistivity. To find resistivity, we need to rearrange this formula. So we will get rho is equal to A will go in the numerator. So R multiplied by the area, which you got here, R multiplied by area, and length will go in the denominator. So this will be the rearranged formula for resistivity. And after you substitute the values, what have you done? You have substituted the values. So let us see the values. R resistance is 26 ohm. It is given here 26 ohms. Area is 7.07. Area here. This is the area which we have calculated. Right? 10 raised to power of minus 8 meter. Everything is in meter. Okay. Millimeter is also converted into meters. And length. What is the length? Length is given as 1 meter. We put 1 meter here and find resistivity. So this resistivity is equivalent to manganese. Okay. So next we see the combination of resistors. What is combination of resistors? What is the resistance itself? Resistance means it is opposing the current flow. More the resistance, lesser the current. Lesser the current will flow into the equipment. Okay. So larger the resistance, more difficult for the current to flow. Larger the resistance, more difficult for the current to flow. That means if it is a rubber has very high resistance and hence a poor conductor. Next, now we will see what is a series combination of resistors. Okay, this is a series combination. In series combination, what happens? One hand is connected to the wire and other hand is connected to the other hand of the other resistor. I'll explain little in detail. So this is very important to understand, others will get confused what is a series connection and a parallel by solving problem. So what happens here? Here current is coming here. The current moves from positive terminal. It goes all the way and it tries to enter this circuit. At this circuit, there is a joint. That means a voltmeter is connected. What is connected? A voltmeter is connected at this joint. And a series of resistors are connected. Voltmeter has very high resistance. Resistance of voltmeter, ideal voltmeter is infinite. That means no current will flow. No current will flow in which direction? In the voltmeter direction. That means I'm showing it in red. That means red, in the direction of red, there will be no current. All the current will flow in the direction of the resistor. That means the current does not break. It continues to remain same in the direction of the resistance. In the direction of the resistance, current remains same. From here to here, the current remains same. Okay. That is why it is a series combination. In series combination, the current remains same. That is why across each resistor, the voltage will be different. Across R1, the voltage will be different. Across R2, the voltage will be different. Across R3, the voltage will be different. That's why it is shown here. We have seen here, voltage V1 is for R1. Voltage V2 is for R2. And for voltage V3 is for R3. If we calculate all this, you will get V total, which is the voltage of the battery itself. This V total will be the voltage of the battery itself. I hope this is clear. So the voltage is different across each resistor and current will be the same for a series combination. So next, now we will see parallel combination. This is a parallel combination. What happens in parallel combination? Resistor ka left hand and right hand is connected to left hand and right hand of all the remaining resistors. That means I am holding my left hand and right hand with everybody's left and the right hand. That means everybody is in parallel, right? If I am standing in series, then my left hand will be connected to left hand of my mother, okay? But my mother's right hand will be holding my left hand, and my mother's left hand will be holding my father's hand, right? That means we are not parallel combination. We are series now. Series. If we were in parallel, then I will hold my mother's left hand to my left hand, and my right hand I will hold my mother's right hand. That means we will be in parallel. So that is a parallel combination. Okay. So if you can see here, this one's left is connecting to left hand of R2. It is connecting to left hand of R3 also. And this one's and his right hand, what happens to the right hand? Right hand is also connecting to R2, and R2 ka right hand is also connecting to R3. That's why it is a parallel combination. This is a parallel combination. And a voltmeter is always connected in parallel, whether it is series or parallel, voltmeter is always in parallel. Okay. So in this case, what happens? The current will split. This is the joint, right? So current will split here. Current will be, one current will go here, another current will go here, another current will go here. So that means three different currents are there. So current will split now. I1 current will be there. Then there will be I2 current. I2 current will go into R2, and I3 will go into R3. Okay. So now what will happen for a parallel combination? For a parallel combination, you'll have a reciprocal of the resistance. Parallel, remember, series means directly addition. For parallel, you need to reciprocate and then take a reciprocal and then add. And here we can add the current. Okay, voltage is same. There is no addition for voltage for parallel. Voltage will be same across all the resistors for a parallel combination. Okay, so now that we have done this, let us solve some problem. So can you try to solve this problem? One, two, three, four, 5. Okay, you can pause it. You can pause it and still try to solve. Okay, or later on you can try to solve. I will share this recording. And then you can pause at that instance and then try to solve it yourself. For now, I will solve it here. Okay. What is given here? An electric lamp. This is the electric lamp here. Resistance is 20 ohm. Right? 20 ohm. This is a 20 ohm lamp, and conductor of 4 ohm. 4 ohms is the conductor, which is having a resistance of 4 ohm basically, right? 4 ohm is the resistance of the conductor. It is connected to a 4-volt battery. This is the, sorry, not 4-volt battery, 6-volt battery. What it is asking? It is asking total resistance of the circuit. What is the total resistance of the circuit? It will be the addition of these two. This two ka addition will be the total resistance of the circuit, right? It's a series combination, no? You don't have to take the reciprocal. You have to directly add 20 plus 4 will give you the total resistance. Next question, what it is asking? Next question is asking the current. It is asking current through the circuit. How much current is flowing to the circuit? We have to remember Ohm's law. Equivalent resistance is 24, right? And voltage is given. Use Ohm's law and find the current. What is asking third? The potential difference across only the the lamp, only across this. It is asking potential difference across the lamp. It is asking potential difference. How you will get it? You already calculated the current. You already know the resistance of the lamp, right? Current is already calculated. So use Ohm's law and get the potential difference. We'll see the step by step. So given resistance is given, conductor is 4 ohms, voltage is 6 volts, connection is a series connection. So then next what you do, total resistance is you add up 20 plus 4. Basically 20, you add up 20 and 4. It will give you the total resistance. Then you get a current to the circuit. Current to the circuit is using Ohm's law. How you will get it? You have the voltage. Voltage is 6 volts. 6 volts is the voltage. And total resistance is 24. This is the equivalent resistance to find the current in the circuit. Current in the circuit is 0.25 ampere. Okay. Potential difference across each component. Now you know the current. Current is calculated. And you know the resistance of the lamp and you know resistance of the conductor also. So you multiply current with resistance, right? To get for each component. For across the lamp current will be same only. It will be the same current and resistance will be 20 ohm, right? 20 ohm will get 5 volt. And next you take for conductor. For conductor, what will happen? Current will remain same. It will be 0.25 amp only. This is a series combination. For series combination, current is same. Current is same for series. Voltage is different across each equipment. Okay, you multiply this with R2. That means the resistance of conductor, which is 4 ohm. You will get 1 volt. Okay, this is the solution. So next problem. Okay, next problem is stating about this is a 3 resistors are given. The diagram I will show the diagram as well. This is a diagram. That means it's a parallel. It's a parallel circuit. What is given in the question? 3 resistors, right? Each resistor value is given 5 ohm, 10 ohms, and 30 ohms. And connected to 20 volt battery. This is a 12 volt battery. How much? It is 12 volt. 12 volt battery. And what it is asking? It is asking current through each resistor. For each resistor, you have to find current. You have to find current through each of them. That means this is a parallel combination. And because it's a parallel combination, what will happen? Current will be different. Here current will be different. To R2 current will be different. To R3 also current will be different. Keep turn on your cameras. Huh? I think okay. So current through each resistor. How we find? We use Ohm's law. Ohm's law is basically current is equal to voltage by resistance. So voltage is for parallel combination. Voltage will be the same. It is 12 volt, right? Voltage will be 12 volt, right? Voltage will be 12 volt. Voltage will be 12 volt, and resistance will keep changing. Okay, 5 ohm, 10 ohm, 30 ohm. Resistance values are different. Resistance values are different. All these three, okay? So for R1 we calculate voltage is 12 volt and R1 is 5 ohm. That is how we get the current. R2 is same voltage is same. Voltage is 12 volt only. Voltage is same. Resistance is different. So you'll get 1.2 ampere. And for R3, you'll get 12 by 30. Okay, that will take the other resistance, that is 30 ohm. So total current in the circuit will be the addition. It will be the addition of all the current, right? You will add up all the current. 2.4, 1.2 and 0.4, you will add up. कुछ लोगों को नींद आ रही है, कुछ लोगों को नींद आ रही है. क्या टाइम हुआ, क्या टाइम हुआ? चाय का टाइम हो गया लग रहा है. हाँ, टी टाइम. So current, total current will be how much? Total current will be addition of all the current, right? 2.4 plus 1.2 plus 0.4, you will get 4 amp. While solving, you also have to solve it on your own notebook. Okay, by looking, you will not able to remember it well. So you have to solve it on your own notebook also. Okay. So total circuit resistance, parallel circuit, that's why you have to take reciprocal. Reciprocal. 1 by R equivalent is equal to 1 by R1 divided by 1 by R2 plus 1 by R3. So you will get it as R equivalent will be how much? R equivalent will be 3 ohm. 3 ohm. Okay, we have seen a couple of problems. Now we'll see the advantages of parallel and series combination. So what are the advantages? Parallel mein, in parallel when you do, the circuit continues to be in a closed loop, even if one of the device fails. That means if you connect devices in parallel, if you connect your TV in parallel with a bulb, a fan and everything will work. Even if your TV breaks down, your fan and heater will continue to work. So that's why each device gets its independence. Each device gets independence, right? When you connect it in parallel, even if one device stops working, then the other devices in parallel continue to function. It will continue to function. Okay, what is the next advantage? Each device, your TV will have a different current requirement. Your mobile will have a different current requirement. Your fridge will have a different current requirement. If you connect it in series, then the same current will go in all the equipment. So one of the equipment will blast, doom, jal jayega. If you connect it in series, but if you connect it in parallel, what will happen? Each line, each circuit will have a different current flowing to it. That is why parallel circuit is advantageous. Okay. So using a parallel circuit, you can connect your refrigerator, bulb, everything, all you can use at the same time if they're connected in parallel. And it gets reduced equivalent resistance, right? Equivalent resistance reduces. It is lesser than the least resistor. And that is why energy consumption is very efficient for a parallel combination. So write down in the chat, what are the 3 advantages? Write down in your chat. Write down in the chat box. By time I'll go to the recap of whatever we have done. Okay, for electricity, we have covered current electricity. We have seen the definition. We have seen that it is the flow of charge flowing to the unit area in a given time. It is measured using ammeter. Okay. Then we have seen the formula for current. Then we have seen electrical potential difference. It is the work done to move the unit charge from one point to other. It is measured using voltmeter. And this is the formula for voltage, work done by charge. Then we have seen Ohm's law. For Ohm's law, potential difference is directly proportional to current flowing to the conductor. It is given by voltage is equal to current into resistance. Then we have seen resistance itself. Resistance may you have seen what are the factors due to which the current will flow. Depends. Resistance depends on length, area, and material. And then we have seen the formula for resistance, which is rho L by A. Then we have seen two types of combination. One is parallel and other is series. And we have seen the formula how you get the equivalent resistance. Okay, resistivity for each type of material, it will vary. For same material, it will be the same. For conductors, insulators, and semiconductor, these are the resistivity ranges. And next session, which will be the final session, we will see heating effect of electricity. That is magnetic effect also. Magnetic effect will come in a completely different chapter. In this chapter, we will cover heating effect and electric power. Okay, thank you. Thank you.
Thank you.